Hello and welcome back to my RC channel. I'm Andy RC and today I'm looking at the Zhiyun Tiny 2 3-axis gimbal for aerial photography use. You may have previously seen my gimbal videos which have been at the cheap end of the market. I reviewed the Good Look Buy 3-axis gimbal which was very good and cheap, however there's a few problems. The first major one is that shortly after I bought it, the manufacturer changed the design slightly. They gave it the same motors all round and a shorter camera plate which caused balancing issues. The gimbal used the Storm 32 controller board which has extensive settings. Hobbyists like me love extensive settings, however you can't just take it out of the box and get decent results from it. It's pretty hard to know what else to go for. The entire world is busy flying mini quads at the moment, so there are not that many video samples of good gimbals going around. Not only that, but a gimbal is not the only component required to get good video footage. If you have a well-built and tuned quadcopter, then you can get really smooth footage even without a gimbal, but a quadcopter with lots of vibrations and a badly tuned flight controller may even make a good gimbal look bad. In the aerial photography world, it seems that the Zemu's H3 3D gimbal from DJI is considered the best gimbal to carry a GoPro camera. They too, of course, have now done away with the GoPro and are concentrating on their gimbals with their own cameras, and no doubt the aerial photography world will be preferring those over everything. I'm not spending $1,000 on a combined gimbal and camera. So back to the H3 3D, and there's a few problems with that as well. Like their new integrated gimbals, it only connects to a DJI flight controller. There's also no yaw control despite it being a 3-axis gimbal, and it only fits the GoPro camera as well. So say hello to the Zhiyun Tiny 2 3-axis gimbal. It is a contender to the Zemu's gimbal in many ways. Quick disclaimer here though, this has been kindly sent to me by Shelly from Zhiyun. I will put her details in the description of this video as she is after more retailers to stock this product. Although I'm happy to say that more of the well-known retailers are going to have this product in stock soon, I will provide links in the description. Let's take it out of the box and see what you get. The packaging is really nice and premium. First we have the instructions and warranty information. I'm a man, so of course I'll be ignoring all those things. We have what looks like a top mounting plate. Then of course we have the gimbal itself. It has this foam pad attached to the camera plate, which keeps it in place while in transit. As we have these adjustable screws, it can fit many cameras to it. I have the Xiaomi Yi and the GoPro 4. It is primarily designed for the GoPro 4 though. As this is a high-end build, I'll be using the GoPro Hero 4 here. Now I know there are cheaper options out there that are just as good, and people will even argue there are options out there that are cheaper and better than the GoPro, but this is what I'm using. It's called the Tiny 2 for a reason. It's very small and lightweight, which I'm happy to see. My first impressions are good. We don't have any visible wires aside from the standard JST power connector. It looks sleek and well designed. You might be thinking, how can it have no wires coming from the motors to the controller board? Surely they will get tangled inside the casing. This is where some clever engineering comes in. The motors have stoppers on the yaw and pitch axis. The stoppers are just short of 360 degrees on the yaw axis, and on the pitch axis around 270 degrees. This is ample for aerial photography. There's no need for stoppers on the roll axis, as the yaw motor stops the axis from overturning. All this means that the wires can be tucked inside and we have a very neat looking gimbal. We don't have any mounting on the gimbal at the moment, so let's see what else we get in the box. We have a black cardboard box containing the mounting brackets, a variety of cables, a USB mini B lead, rubber vibration balls, a bag of screws with an Allen key, as well as rail mounts, 2 safety clips to stop the gimbal becoming detached from the mounting plate, and this USB cable with a JST connector on the end of it. First of all, let's talk about that USB connector. It is a connector for the GoPro Hero 4 that directs the camera's video output into the side of the gimbal and out through the top of the controller. This is exactly what I was after. No messy wires that could cause friction with the gimbal. Everything feeds internally. It also charges the GoPro as well, so no batteries going dead on us here. Let's unravel the wires and see what else we get. We have this yellow and black wire. This is our video out lead to our VTX. We then have a male JST connector, which we need to solder to our quadcopter's power distribution board. Then we have the GoPro connector, which I already talked about. We have the wires that connect to our receiver to control the different axes and modes. And of course the USB Mini B lead, which is also branded. We can use that to update the firmware and recalibrate the accelerometers if we need to. The manufacturer advises you to do that, especially if you live in a country where the temperature is vastly different to China, which is where it will originally have been calibrated. I know that this is meant to be an out-of-the-box working gimbal. The fact is, though, that all gimbals need some kind of calibration. I see countless posts of people complaining that their Inspire 1 or P3 does not have a level horizon on the first flight. They are initially calibrated in the factory in China and will need recalibrating when you receive it. Same goes for this gimbal, and I'm happy to see that we have that option. I did try to fly the gimbal out of the box. It worked well, but I had a slight tilt on the horizon. So let's talk about how to recalibrate it. Visit Zhiyun's website and navigate to the support and download section. You will need to download the Gimbal Tools program and also the USB driver. If you have already installed VCP, which stands for Virtual COM Port, from ftdichip.com, then you won't need this USB driver. Under the Tiny 2 picture, you can also see a firmware download option. We will grab this too. I will explain why in a bit. Again, you will need WinRAR to extract these files. First, install the USB driver if you don't have it already. I have put the two other folders in my RC software folder. Run the Zhiyun Gimbal Tools.exe file and a program will open up. It's a very simple piece of software. Select the product at the top right, which in this case is the Tiny 2. Then plug in your USB lead into the side of the gimbal and also the computer. If you installed the USB driver correctly, then a COM port will show in the top left drop-down menu. In my case, it's COM4. You can see that we have two tabs that are labeled IMU calibration and firmware upgrade. As mentioned in my previous videos, IMU stands for Inertial Measurement Unit and is basically a posh word for accelerometers. We need to press open and then plug in the power supply to the gimbal. In my case, to do the calibration, I used a 3S battery. Once the battery is connected, you will see the gyro and accelerometer data populate with live data. Now if you press calibrate, you'll get some pictures in the bottom half of the program showing you the orientation in which you must place the gimbal. I'm not going to calibrate mine again here as I've got mine perfect already, but I must stress that you need to follow the diagrams and be as accurate as possible. The diagrams will show blocks being placed under the gimbal. My recommendation is to choose a very flat surface, find household items that are square and of different sizes, and make sure that everything is as level as it can be in relation to the pictures. If you do this well, then you will have a really nice horizon. If you do this badly, then you won't. In fact, this is the case with all gimbals. The more accurate you can be with the IMU calibration, the better the horizon will be locked in. It's not really much to do with the gimbal itself. If you watch my Storm 32 video, I use the spirit level to do an accurate IMU calibration. It's not really practical though with this Tiny 2 gimbal. Luckily, this is a 6-position calibration, so as the controller board is taking multiple readings, a couple of slightly inaccurate captures should not affect the overall result too much. It didn't in my case anyways. As mentioned, you will be taken through a series of diagrams. Only when the gimbal is 100% still in the position shown, it will then let you move on to the next position. Once you have completed all the positions, you can disconnect the USB from the computer and power cycle the gimbal. Next, I want to talk about upgrading the firmware. You might be thinking that this is getting a bit technical, but it's important. Out of the box, the gimbal comes with what the manufacturer calls the S version of the firmware. This means that when we move the gimbal using the sliders or potentiometers on the transmitter, the tilt angle will carry on increasing until we return the slider to the center. This is fine on my Tyrannus as I have a center notch, but if you haven't, this is where you will want to install the P version of the firmware. P stands for position. This changes our RC inputs so that when we move a slider or potentiometer, the gimbal will stop in the position our slider stops. There are a few downsides using this mode though with the Tiny 2. We no longer have the 360-degree rotation on the yaw, it's more like 180 degrees. In heading lock mode, we are not able to control the yaw movement either. And we are also not able to look up with the version of the firmware that is available, which is version 1.20. It seems that the Zhiyun website only lists version 1.20 of the firmware. However, I found that version 1.11 of the P firmware allows full up and down pitch of the gimbal, so if you are stuck to that mode, it might be worth downloading it. I have got both versions here just to try out. To upgrade the firmware, make sure you have the Tiny 2 selected in the product list. Plug the USB lead into the gimbal, but don't power it up with the battery yet. Select the Firmware Upgrade tab, click Browse and navigate to the Firmware folder. Select either the P or S firmware depending on your transmitter's abilities. Press the upgrade button, a timer will then count down to allow you to plug in the battery to the JST connector on the gimbal. The firmware will then start to upload to the board. You are now good to go. You can unplug everything from the gimbal and computer. Without any of the mounting or a camera attached, the gimbal weighs 200 grams. The mounting plates are pretty unique. To save weight, they directly screw into the controller board using the screws provided. You want to make sure that you have them the right way up, otherwise they don't reach the top plate. All of the vibration dampener balls seem to be the same weight in my kit. They feel fairly weak in strength, so I'll have to see how they perform in flight. It's not hard replacing them with stiffer ones. I've got plenty in my spares bin. The top plate then fits on the 4 dampeners, and check this out, the top plate has a recess in it so the dampeners fit flush. It's a really small thing, but it clearly shows that the manufacturer has really thought about the design of this. We have various screw holes in the top plate for mounting options. However, as I have installed the rail system, I'm going to install the rail connectors provided in the gimbal kit. These screw in with an Allen key again. It might be worth using Loctite if you plan on keeping it this way. With all the mounting and a camera attached, it weighs 324 grams. Lastly, we have the connections to the controller board. The power connector is a JST. It accepts 3 to 6S, so no need for a regulator there. We have 2 female JST connectors after that. The first one is for our mode selection switch. The gimbal has 3 selectable modes, but I will get into that later. The mode selection wires are connected to a servo lead. The servo lead provides a regulated 5 volts out. The idea of this is to power your receiver from it, so be careful. As my receiver already takes its power from the Pixhawk flight controller, I will be removing the center voltage wire. It's a neat idea though. Maybe I can use that regulated 5 volts for other applications. Next wire along, and we have our RC inputs. The brown cable is pitch, the blue cable is yaw, and the yellow cable is roll. The other female JST connection is for our video out lead, which I'm going to solder a servo wire to, and then connect it to the VTX. It's a shame that this lead didn't come with a servo connector attached to it, but I have a few of those lying around, so I'll solder one up. So I have assembled everything and attached it all to the quadcopter. You have to bear in mind that to have all of the connections hooked up from this gimbal, we will be using 4 channels on our receiver. You can see that the gimbal fits to my rail system nicely. There's not a lot of ground clearance with my undercarriage, but there's just enough. The gimbal hangs really low, which I like, because with the gear lifted, we should not have any of the quadcopter in shot. I have soldered the JST connector to my power distribution board on the quadcopter. It looks quite messy in there, but it does all work. I just have to be careful not to desolder the current connections. I have connected the mode and RC pins to my receiver for now. I know people will advise me to connect them to the Pixhawk, but I'm not too interested in the Pixhawk taking control of my gimbal, but maybe it's something I can do at a later date. You can see I have got the pitch, yaw, and mode inputs plugged into channels 10 to 13. I have created entries in the input screen and the mixer screen on the Taranis so that my pitch and yaw are done on the sliders on the side of the Taranis. The mode switch I have connected to a spare 3-position switch on the Taranis. In this case I've used the SC switch. Initially I hooked it up to the S1 potentiometer. This is because the manual stated that there are 4 gimbal modes and there are no 4-position switches on the Taranis. It turns out though that there's only 3 modes that I could find using the potentiometer, so I moved it back to my 3-position switch. Using an Android voice recorder, I then recorded myself saying the different modes out loud and then added the WAV files to the SD card of the Taranis as shown in previous videos. I then hooked the sounds up to the mode switch. Gimbal follow mode. Gimbal heading lock mode. Gimbal reset. Before we boot the gimbal up, you can see that a GoPro Hero 4 with battery balances perfectly with its body flush to the side of the gimbal. To balance the Xiaomi Yi, I have to move it a bit further along the camera plate, but it doesn't need much adjusting to balance that either. Of course, if you want to use the video out of the Xiaomi Yi, you can make yourself a custom connector, but the stock cable is designed for the GoPro Hero 4 only. Let's put a battery in the quadcopter and boot it up. The first mode is the follow mode. We only have control of the pitch and roll axis here. The idea of this is that we use the quadcopter to do the yaw. Another thing to take note of is that the tilt controls are always absolute. This means that if I move the slider, the gimbal will tilt and then carry on moving until I recenter my sliders. This isn't a problem for the Taranis, as the sliders have a clear notch where the center is. Also, if you're not viewing the FPV footage from the GoPro, then you won't have any idea of the angle the camera is pointing at if you have altered it via the sliders. That being said, I have seen people install joysticks on the Taranis. This will be a much better method to control this gimbal as a joystick recenters itself. In mode 2, this is heading lock mode. Here, no matter the orientation of the quadcopter, the gimbal will lock its heading. We can then control the yaw on the gimbal independently to the quadcopter, as well as the tilt and roll axes. You get almost 360 degrees of rotation on the yaw as well. The gimbal doesn't freak out when it reaches its maximum position either. It just stops in its place and returns to its fixed heading once the quadcopter yaws back into position. The third mode resets the gimbal to its center. There is no yaw, pitch or roll control in this mode though, so after you have reset it, you can flick back into mode 1 to regain your controls. I have decided not to use the rail mount that comes in the kit for now. This is for one reason only. The rail mount system is very good and it hooks up really nicely. However, I have two quadcopters that I plan to use for aerial photography. They both have the same rails, however they can both use the same FPV camera. My rail system comes with this plate that you can sit your FPV camera on. I have cable tied the Zhiyun top plate to the FPV plate, and now I have a movable pod that I can switch between both aircraft. You know how much I love swappable FPV plates. I have also switched the stock rubber vibration dampeners for stiffer ones. Again, the ones they send with the kit are perfectly adequate and will get you great video footage. However, it's the middle of the winter here, and frankly, it's blown gales all of the year. I can't remember when there was a good flying day. It's been shocking and really frustrating, as you can probably tell. I have been waiting 2 weeks to get a day with no wind or rain to try this product out, but it's just not happening. The stock vibration dampeners work, however they are quite weak in strength. I can see why Zhiyun have done this. Weak vibration dampeners will iron out any jello caused by vibrations and in general a badly tuned aircraft. They can't guess what all of our setups are going to be, so it's best to provide vibration dampeners that get rid of the most vibrations. Like everything, this comes at a cost though. Weak vibration dampeners are susceptible to outside forces, for example the wind. The wind has rarely been below 25 miles an hour for months here, so using the stock dampeners, the gimbal just gets knocked about. Both of my quadcopters are using premium parts, so I can get away with using really stiff vibration dampeners, which will give me rock solid video footage even in gale force winds, which I will be displaying later. Using the stiffer vibration dampeners also means that the safety clips provided in the kit fit really snug. However, due to the tighter fit of the dampeners, the clips are not really needed, but I put them on anyways. Despite not using Zhiyun's stock rail solution, I haven't really gained any more ground clearance, so both of the solutions are really good. This is just what I'm choosing to do so I can use that FPV camera on both aircraft. As you can see, the plate fits nicely on my high-end 450 size quadcopter, as well as the SK450. I'm going to use the SK450 to do the test flight for a couple of reasons. First of all, it's the aircraft that I use for the Good Luck Buy gimbal, so I can compare the results of the two. But also, it has the smaller 8-inch props. It gets less affected by the wind. I do use this term lightly though, because despite that fact, it's still going to be really tricky to fly. The SK450 is also using UHF for control, so if I get blown away by the wind, I should have a good enough signal to get it back. Now that's everything explained, let's see how it performs in the air. I went into this flight not expecting any results. It's a 25-mile-an-hour wind and it's raining quite hard. You wouldn't know it though, just look at this footage. Normally I wouldn't even try to fly in this weather. My high-end 450 size quadcopter couldn't even hack it. I wouldn't ever advise flying in the rain either. However, it seems that the quadcopter has shielded the GoPro from any raindrops. I have removed the soundtrack from the GoPro because the wind noise is very unpleasant. I don't manage to fly very high due to the crazy weather. I wish I had filmed the aircraft from the outside because I was fighting it the entire time. It was too windy for any kind of GPS hold, so this was done in full manual mode. I pitched the gimbal down here to see how stable it is when the gimbal is at a lower angle, and it's just absolutely locked in. I flew the aircraft line of sight despite having the FPV link working. The FPV footage could never have shown how much input the aircraft was needing to stay in the air. I played about with the tilt controls as much as I could. One thing to look out for is its horizon lock. The field that I fly in slopes downward slightly, so at times it looks like the horizon is out, but believe me, it's totally locked in and straight. You can see sometimes when the aircraft is higher up that the horizon is perfect. This is exactly what I want. I go into the heading lock mode for a very unflattering view of the quadcopter. I can't wait to be able to put the aircraft into GPS hold mode and look around with the camera. You can see that the gimbal keeps its heading until the aircraft yaws to its extreme, and then it follows the aircraft until we return back into its range. Now you can see there I have selected mode 3, which completely resets the gimbal's position, and again you can see that the horizon is locked in absolutely perfect. Just check above the houses there and we've got no drift whatsoever. You can see here that this field does drop down slightly to one side, but then when the aircraft lifts up, you can see the horizon is completely locked in again. Just check out these trees here. You wouldn't believe how windy it was from this footage, but the trees are swaying. And again, I have yawed around there, and you can see the horizon is completely straight as we get higher up, and you can see further away. One thing I did do is remove the roll RC pin from the receiver. I found that the center notch on the Tyrannus's potentiometer had no dead zone. That can easily be programmed in, but without it, the inaccuracy of the RC input will cause a slight roll drift, which is not something that we need. The horizon is so locked in anyways, so I removed the pin. I am so impressed with this thing that somehow in these conditions we don't have any vibrations, any wobbles, we didn't have any PIDs to tune, it just works great. I mess with the tilt angle some more and pitch fully up so we can see the underside of the SK450. My voltage alarm is going off, so I'm trying to concentrate on a safe landing. It's going very dark, very fast here. The light disappears within minutes in the winter. So there you go, this is the best 3-axis gimbal I have by far, and I totally recommend it. Thanks so much for watching, and also to Shelly from Zhiyun for sending me this product. I hope you enjoyed the video. Please continue to subscribe. Cheers.